Cellular automata is a computational model in which a grid of cells evolves over time based on simple rules and updates its state depending on the states of its neighbors. Each cell can be either true or false, 1 or 0, black or white, wall or empty, ground or water. You get the idea. A key feature of cellular automata is that time progresses in discrete steps called generations or cycles, not smoothly like in the real world. Time is chunked into steps. Particularly in this program, cells follow such rule. A cell becomes black in the next cycle if it has more than 4 neighbors, otherwise it becomes white in the next cycle. At the top of the viewport is the header. It contains five control elements. Cell size. I can change its cell size in the grid. Grid toggle. Show or hide grid lines. The density slider controls how much of the map is initially filled. Time is frozen. You control it with 2 buttons. Next will calculate the next cycle. Previous will return to the previous one. It is possible to toggle any cell manually. If I click on any cell, it changes its states to the opposite. Let's take a look at the code. As always, all is packed in one HTML file, with internal CSS styling and embedded JavaScript. The HTML structure and CSS styling are basic, and there are enough comments to explain them. The same is true for JavaScript. The program structure is linear. Commentaries explain every step and variable. That is why I want to clarify only the 2 most advanced techniques used in JavaScript. Function nextStyle calculates the next generation of cells. It must loop through each row and each column, pick up every cell, and calculate how many neighbors this cell has. Depending on the number of neighbors, decide whether this cell is in the next cycle will be 1 or 0. To do that, firstly I need to iterate over all cells in the cells array. It is simple. One for loop for rows and one nested for loop for columns, like that. But the thing is that the program loops through all cells in 3 different places. Look. First place in next cycle function. Second place in draw cells function to render them on canvas. Third place in initialize canvas cells function to populate the first initial generation. What it means? It means that I will be forced to type the same code pattern 3 times. It is not good. If the same code is repeatedly typed, it is a sign that it can be optimized to make code compact, maintainable and professional. That's why the decorator function scan cells is implemented. The decorator function is a function that accepts other function as an argument and enhances it without modifying it. As a result, I have these 4 loops to iterate over each cell written only in one place, in the decorator. Second point of interest in this code is how the algorithm counts cell neighbors. To apply the rule and decide whether a current cell will be 0 or 1 in the next cycle, the algorithm needs to count the number of neighbors for the current cell. To do this, we check all 8 surrounding cells in a 3 by 3 grid around it. That's why we use -1, 0, 1 array for both x and y directions. For each neighbor position, we first check if we are looking at the cell itself. When both x and y are 0, we skip counting that one. For all other positions, we check if that neighboring cell exists in our grid. If it is outside the grid boundaries, we treat it as a living cell, count it as 1. If it exists, we check its current state, 1 for black, 0 for white, and add that to our count. The double reduce functions let us systematically check each position around our cell, first looping vertically, y direction, and then horizontally, x direction. For each vertical position, we are essentially scanning the neighborhood in an organized way and accumulating the total count of living neighbors. The file location is in the description. I will scroll the whole HTML file now. That's all for now. Have a nice one.